Okay, so let's look at another type of word problem where we can use the ideas behind quadratics. So say we have 2,400 feet of fencing for a rectangular area. So that means I got a rectangular area. In my rectangular area, I only have 2,400 feet of fencing. So that means this fencing, this fencing, this fencing, and this fencing can only add up to 2,400. So that is a perimeter. Hopefully you remember that. When you have a rectangular area, you have a width and a length. And my width and my width and my length and my length, or my 2w plus 2l, has to equal 2,400 because that's all the fencing I got. Okay, so without even getting a question, I already got kind of an answer. Well, kind of an equation, not an answer. So I want to try to write a function for the area in terms of width x. So area, hopefully you remember the equation for area. Area equals length times width. And in this time I was told that my width is x, so I want to use x. So instead of length times width, I'm going to have length times x. And I really don't want an L in there. I want my only variable to be x. So I'm going to do some substitution. I'm going to say, well, I have another equation that has a width and a length. And again, I'm going to change that width to an x. And I'm going to try to solve that for the L. So if I solve that for the L, I'll get 2L equals 2,400 minus 2x. Continue solving it for L, I'll divide by 2. So L equals 1,200 minus x. So my L is 1,200 minus x. These are my relation between my width and my length. And I'm going to be able to sub that into my area equation. Area equals 1,200 minus x times x. Okay, so I wrote this as a function of the area, and I wrote it in terms of just the width x. Can multiply it out if I want to. Area equals 1,200x minus x squared. Okay, so say there was another part to this. Say I want to find the dimensions that maximize the area. So again, there's that word max in here, maximize. So I'm going to go ahead and try to find the dimensions that maximize the area, given this area. So I'm going to write it with my x squared first, because I'm used to seeing that, plus 1,200x. And I'm going to say, okay, well, again, this is going to be the shape of a parabola, and it's got a negative in front, so it's going to be an upside-down parabola, so it is going to have a max. So I can find that max. The max is going to be at the vertex. And I can find that vertex. Vertex again is negative b over 2a for my x coordinate. I would just sub that back in to find my y. So b is 1,200, so negative 1,200 over 2 times negative 1 would be negative 1,200 over negative 2, so 600. Now I actually don't even have to sub it back in this time, right? Because this is just my x. X was the same thing as my width. And up here, I found that I had a length in terms of x. My length was 1,200 minus x. So if I write that out, length equals 1,200 minus x, sub that in, again, just my width, so x is 600. So 1,200 minus 600, I'm going to get my length to be 600. So my dimensions that would maximize stuff would be 600 times 600. And it seems a little weird, because with this, the other one with the throwing a ball up, we could kind of see how a parabola would help. With the area, you got to remember that what you're looking at when I'm doing my x and my y is I'm saying if my width is 1, what would my area be? And my area would be pretty small. If my width was 2, my area would be a little bigger. If my width was 3, my area would be a little bigger. So I'm trying to see which width would actually get me the biggest area. So it's not like this is the length, this is the width or anything. If my x is my width, then my y in this case is my area. And it's just trying to get me to see what area would actually get me the highest, what width would actually get me the highest area. Okay.